My name is Ulrik Stridsman. I work as a software engineer in the NSO CTO team. I have a lot of customer interactions, and that's, I think, why I actually got in touch with the NSO HA. So I was actually asked to give an overview of what we have done in changing the HA in NSO to make it easier to use and make it work for all of our customers, and how we would like to actually change it in the future. Starting with just a quick history. We have some APIs in NSO. One is the HA API that actually makes you able to control how NSO works, how you set up which node is primary, which one is the secondary. And that has been available from NSO version 1.0. So initially you needed to create your own integration with the HA framework of your choice. And that has not been, it's been a quite good challenge for a lot of our customers. So what we actually did is we created a package which we called tail-f HCC. I think most of you are aware of it and are using it. It was introduced in the NSO 3.x series of versions. I don't have the exact date. And it was actually just a package you install. And with that package, you just enable HA and you get replication. In the case of failure, it's just short for high availability cluster communication. As I said, it was a simple framework. And in case of failure, it handles that and then switches from the primary node to the secondary node. It can also handle virtual IP. As you change this node, you would probably redirect the traffic to the secondary node that now is the active one. We also had implemented the possibility to advertise the VIP over BGP. And in this solution, we used Quagga, and in combination with our Quagga NAD and using device templates to configure Quagga to do the proper advertising of the virtual IP. Let's look a little bit forward. So what do we have now? So now we do support replication to 1 or 2 nodes. We can do a synchronous or asynchronous replication. We can support automatic or manual failover. We support virtual IP. And we support advertising of virtual IP over BGP. So the question is, what have changed? And we also have alarms and failure, because in case of failure, it's important to actually notify northbound system that something has happened, and then you probably need to do any intervention to solve the issue. So what have we then actually done? And starting with NSO 5.4, we actually moved the HA framework from within the tail-f HCC package into NSO. So now it's built in. We improved a lot around the startup behavior. I will come back to more details around how that works. And we added auto recovery features, because that, in case of failover, in the old version you probably lost the redundancy. So now we have added improvements of that. We still have virtual IP. It's nothing new. The difference is now when you want to advertise virtual IP over BGP, so now we have a more lightweight implementation using Go BGP. So there's no need for installing an extra NAD, and there's no need to creating device templates. So you just create your configuration in an NSO, and then it, I would say, more or less works. Then we had a few versions, and in NSO 5.7, I would say we did the most important change we have done, and that is we added a rule-based consensus algorithm to avoid split brain. Split brain has I would say probably been the most annoying behavior we had with the HA. So that has been very requested to trying to avoid. And the main reason for split brain is mostly human error. But also, when moving into a geo-redundant setup with NSO, there's more likely to be network problems. And then we also added some improvements in our web UI. So now you have a view in the web UI where you can get an overview of your HA cluster. And now, in the newly released NSO 5.8, we added a package upgrade feature to simplify the management of packages in your HA cluster. And this is actually to reduce the downtime. A few words about the built-in framework. So now, to use HA, you don't need to install any extra package. You just start that NSO as usual, and then you just add configuration. It does the same. It handles replication, it handles failover, and it has alarms. So we just move that into NSO to make it easier to start up. But you still need to edit the nss.conf file to enable HA. And we still have kept the tailf-acc package, but now it's only used for setting up the virtual IP and advertising over BGP. Few notes about the YANG. This was the classic YANG. We had the top container called HA. And from NSO 5.4, we renamed that to high availability to still be backwards compatible. But it still contains the same metadata to set up HA. The startup behavior, I would say, is also one important thing to make the solution more hands-off. Now, when you enable HA, it's persistent. So if you restart your node and NSO starts up, HA will still be enabled. We just have some different terminology in which role a node should be. But we also have this, I would say, the important join HA setting. That means that is part of the auto recovery feature. So when the cluster starts up and it can find an already primary node, it will connect to that one. I also mentioned auto recovery. And we also have this reconnect slaves feature that when there is a failover and you're running multiple secondary nodes, if they lose the primary node, they will continue looking for is there primary node running, and when it finds it, it will reconnect. I will have some examples of that shortly. Split brain prevention I've talked about. We'll talk more about that in a second. And then now in NSO 5.7, we added this rule-based consensus algorithm to prevent split brain. And we support that with 2 or 3 node configuration. Our goal is in the future is to get some kind of leader election, quorum-based leader election, to actually get some security around that, because there will more or less always be situations where split brain is unavoidable. Let's go back to some history. How did HA work when there is a network error? We have a primary node and a secondary node set up. Replication is enabled, so we have redundancy. There is network error. What will happen? The primary node will just continue as before, but with the notion that, oh, I don't have any secondary node anymore. And an alarm will be raised. The problem occurs when we have this secondary node set up as failover, so it will detect I lost my primary node. So it will do some reconnects, and when that fails, it will also do failover. But first, when it loses its primary, it will just end up in state none. And then after when the reconnects are consumed, it will also be primary, and we have this split brain situation, which is not an ideal situation, because now you need to actually sort out which has the latest transaction. So how did we then solve this with the rule-based consensus algorithm? This is an example where we have a network error with a two-node setup. We have a primary and a secondary set up with replication. There's a network error. This is where we have the first difference. When the primary node loses its secondary, it will step down into state none, say I'm not available for service anymore. And then the secondary node will also, this in the previous example, detect that I lost my primary, and during the transition period it will be in state none, but then it will step up and be primary. So in this situation we don't have any split brain situation. But this, of course, is depending on how does the network topology looks like. What if this happens? Can we be sure that the network error is in the characteristics that it is the primary node that loses connection to the production system, or is it the secondary? Then we have this situation setup where you can run this in a three-node setup to actually secure redundancy even better. We have the same error. In this case, we have a network error. So both the failover secondary and the secondary, I hope you will follow that terminology, loses connection with the primary. This means that all nodes will just step down and be in state none for a transition period. And now the consensus algorithm kicks in and starts resolving. We have these reconnects. And when the reconnects have been consumed, it was like the previous example, the failover secondary will step up and become primary. But there's a small difference. Now it will be in state read-only until we have the secondary that will still trying to reconnect to its primary, but now it finds a new primary and it will connect to that one. And when this happens, the primary node will step up and become read-write again. So we don't have any split brain scenario, and we have restored redundancy. A quick review of a different kind of network error. In this case, the secondary loses connection. The primary will continue to be primary in read-write mode because it didn't lose any connection with its secondary node. And then when the network connection is restored, the secondary node will connect to the primary, and we have restored redundancy with three nodes. Then just a few words about the changes we did in our web UI. In NSO 5.7 we added this view, so you can more simplistic, you get an overview of the status of the system. You can do this in the CLI. So this is an informational view to get better overview of your system, of your HA cluster. And then in the latest version, now in 5.8, we added this package upgrade feature to actually simplify management of your HA cluster to minimize downtime, because time is money, and We've been asked to actually implement this for quite a long time. So you have this simplistic view where you can upload your packages, and by clicking on one button you can upgrade your system. I wish I had time to actually do a demo of this, but you can just reach out and I can show you. And then we also have some when we don't have the features built in NSO, we have over the time we've created some packages to support more use cases when it comes to HA. And one use case that some customers of ours are using is they have a load balancer in front of NSO instead of using virtual IP. So we created one package we called HA Portier that is just a simplistic port forwarding application in front of NSO, just telling when this port is available, then this NSO node is available for services. We have a second package called HA Status that can also be used for supporting load balancer, and that is authenticationless HA Status. And the reason for that is that you don't want to create a situation where we need to update the username and password in your load balancer at regular intervals. And these packages we provide them as is. So we don't provide any support, but eventually we might put this into the core of the HA framework we have in NSO. And I think that was it, but I have some few words about the future. I've heard a lot about Kubernetes today and containers, and we are doing some work actually in that area, trying to focus on how can we make the HA solution more more seamless and hands-off in a container environment. So if you have any questions, so please reach out to us. Thanks.
Thank you, Ulrik. Maybe we have some questions from the audience on the HA topic. Yeah, so we have down there. I can also tell you that we have, for the first time, we're ahead of the schedule. So according to, if we compare to 2019, we have improved in performance a lot. I think we. I've asked Håkan to actually do that demonstration that he talked about on container orchestration. So while you're answering questions, we'll try to swap in his computer. So
please do.
Okay. So my question is regarding the failure detection of network failure, right? In the example with 2 nodes, if I understood correctly, the new behavior is for the primary node to fall back to none state, and and the secondary would assume as master. Yes. So how does it differ, or how does it identify a network issue versus a slave failure and becoming without a master because it reached the none state? And if that none state is...
I would say it doesn't.
Okay.
So I think we will have the same situation, and this is something that we're looking into, finding ways to actually improve this with some kind of quorum-based solution. So if there are 2 nodes available, they will continue running with restored redundancy.
Mm-hmm. And it will still work because the none state is right enabled.
Exactly.
Okay. Okay. Thank you.
One question more.
Hello. Yes. So in this non-state condition, they will still accept transactions, or they will not?
Yes. I think in this case it will accept transactions. The more normal situation when NSO is in non-state, it will accept transactions. Then on top of that, we have a read-only mode that we, for some of the situations, we enable read-only to actually force prevention of transactions. Yep. Normally, it depends on how you set up your system. If you have a load balancer on top, the load balancer will tell which node is available for transactions.
Yeah, I believe yes, it should accept, because otherwise we'll have service outage, right? We'll have 2 NSO instances. Both of them are not accepting transactions, so it will be a tough situation, right? So I hope that they will continue accepting transactions normally without identifying this state, because as you said, in the normal setup, if they don't have a specific state, they will not accept any transactions unless they are primary, right?
I would say yes.
Yeah. Okay. Thank you.
Hello. I've got a follow-up question about the read-only mode. In the scenario which you mentioned around the 3 nodes where the failover master loses connectivity to the master and becomes none and then read-only, you mentioned it's going to become read-write once it's going to establish connectivity with the third secondary. But what in case the third secondary is not going to be reachable from that failover master that became read-only? Will it remain read-only, or
it will remain read-only? So that's a situation where we have a 3-node system, and it loses 2, so there is no quorum anymore. So it will remain read-only. And that's why it's important to actually monitor your system, and if there is an alarm, you need to keep track that to actually find the error manually.
Okay, thank you.
Thank you. Hello. The NSO upgrade feature that you're saying, is that per NSO node or per cluster?
Can you repeat?
Sure. When you're using this NSO upgrade package,
yeah,
and you're putting a new package there or just upgrading an existing package, you got to do that per node, per NSO node, or per cluster?
Per cluster. And I also think if you run LSA, you need to do it per CFS level and RFS level.
Question here, Mark. Ulrik.
Yep. Okay. Hi, Jan.
My question is there any negotiation algorithm between the peers which would decide which one become primary, so the rest would be secondaries?
No. Currently, there is no. It's very simplistic. If you have one primary, the secondary will just connect to it.
So it's just a simple state machine, right?
Yeah. But this is something that we're looking into, actually finding a more I would say reliable, a more flexible algorithm like Raft or something to make this more flexible.
Yeah, I think this is probably the second next step to consider negotiation algorithm that would decide, so they would negotiate between themselves and decide which machine will become a primary.
Yeah. This is I would say the ideal solution that we would like to have, but currently it's very simplistic.
Okay, thank you.
Okay, thank you very much.